Alright, this video is on data analysis, alright, Unit 6, Part 1, and this was a test. So if you're watching this, maybe you are studying to do recovery. So check it out. Hope it helps. Which of the following is not a sampling method? Yeah, we had cluster, stratified random, simple random, voluntary response. All of these are sampling methods, but block is not a sampling method. So there you go. Okay, which of the following are true? Okay, Roman numeral 1. Voluntary response samples often underrepresent people with strong opinions. Underrepresent means there's too few. There's fewer people than there should be. But that is not true. Okay. When I explained to you why voluntary response was biased by its very nature, I said that when you volunteer yourself to fill out a survey or something, it's usually the people that have strong opinions. So it's really the opposite of this is true. Most of the people that bother to fill out a voluntary survey are doing it because they have strong opinions. So you're going to have a bias because of too many people with strong opinions. So that one is definitely false. Okay, how about the next one? As the size of the sample increases, the margin of error decreases. Okay, remember the margin of error is equal to 1 over the square root of the sample size. Okay, so as the sample size increases, for example, if we had a sample size of 10, and then we had a sample size of 100, and we had the sample size of 1,000. Okay, this is the sample size increasing. Now let's see what happens to the margin of error. Alright, so if I go to my handy dandy calculator and I do my 1 over the square root of 10 first. Okay, so that's 0.31. Okay, now let's make it 1 over the square root of 100. That's 0.1. And 1 over the square root of 1,000. Okay, that's 0.03. Okay, so it went from 0.31 to 0.10 to 0.03. So as the sample size is increasing, the margin of error is decreasing, which makes sense because we're dividing by a bigger and bigger denominator. So of course, that's going to be a smaller value. So this is definitely true. Okay. So what about the third one? Questionnaires with neutral wording are likely to have biased responses. Well, that's just silly. Okay, the neutral wording is how you get unbiased responses. So that just didn't even make any sense. Okay, so only 2 is true. So everyone should have put D. Okay, number 3. A graduate student conducts a study to determine whether a new activity-based method is better than the traditional lecture of teaching statistics. Okay, let me highlight this as we go. So we have activity-based method to see if it's better than the traditional lecture. All right, so activity-based versus traditional. He found a teacher, Professor Perky, who agreed to try the new activity-based method in 2 classes, and the traditional lecture in 2 other classes for the entire semester. Each of the classes has approximately 40 students for adequate replication. At the end of the semester, all sections would take the same final exam and their scores would be compared. What is the explanatory variable in this study? Okay, the explanatory variable. Now we talk about explanatory. All right, versus the response variable. Okay, the explanatory variable is the potential cause of something. Okay, the response variable is the possible result. Okay, so it's like cause and effect. So in this case, the explanatory variable is the teaching style here. It's whether they're doing activity-based or traditional. And then the response variable is, you know, the final exam score. Okay, so the question says, what's the explanatory variable? That's your teaching method. Okay, so if there are treatments, the treatments are going to tell you the explanatory variable. Okay, so it was D. That's the bottom line. All right, moving on to number 4. A committee on community relations in a college town plans to survey local businesses about the importance of students as customers. All right, from the telephone book listings, the committee chooses 150 businesses. Of these, 73 return the questionnaire mailed by the committee. The 73 return questionnaires are used. What sampling method was used for the survey? Well, bam, that's definitely voluntary response. Okay, they mailed out the questionnaires, and you know, if you wanted to fill it out, you did. If you didn't feel like filling it out, you didn't. All right, less than half of the people who were sent a survey actually did it. So clearly it was voluntary. So that is E. All right, let's move on to number 5. In a double-blind medical experiment. All right, basically they're about to ask us what double-blind means. So remember, the 2 blinds in double-blind is that the researcher doesn't know who's getting the treatment, and the subjects do not know who's getting what treatment. Okay? So nobody knows. That's why it's double-blind. So the patient knows? No. The number of subjects and treatments is unknown. No, that's not it. Okay, the doctor knows the treatment. Okay, doctor knows? No. Nobody knows. Both the treatment, both know the treatment, and both are blind. Okay, none of that makes sense. Okay, a higher person knows the treatment, but neither the doctor nor the patient knows the treatment. Yeah, D. All right. Obviously, somebody somewhere has to know, so they can, conduct the study. But the subject doesn't know the treatment, nor whoever's conducting the experiment. The researcher who's actually collecting the data. So the answer is D. All right, number 6. Okay, find the sample size required to achieve a margin of error of plus or minus 2.45%. Round your answer to the nearest whole number. Okay, so we're talking margin of error. So the formula for margin of error is 1 over the square root of the sample size is equal to the margin of error. Okay, so since the margin of error is 2.45%, we would write this as a decimal as 0.0245. So we're just going to take that and substitute it for a margin of error. Okay, so that tells us that 1 over the square root of the sample size should equal 0.0245. Okay, so it's just a matter of solving this for n. Now what I have recommended is just doing the reciprocal at both sides. So this gives you that the square root of n is equal to 1 over 0.0245. Then it's just a matter of squaring both sides, okay, and that's going to give you your sample size. Okay, so to the calculator, Batman. So if I do this squared, so if I do 1 over 0.0245 squared, okay, this is my sample size. All right, the sample cannot be a decimal, it has to be a whole number. So we're going to go ahead and round that. I see that's 0.9, so we're going to round this up. So 1,666. All right, number 7. A survey reported that out of 3,500 people, 76% own a smartphone. Find the margin of error for the survey. Well, again, the margin of error formula is 1 over the square root of the sample size. They just gave us the sample size is 3,500. So this is just a straightforward application of the formula. Okay, so let's do that. 1 over the square root of the sample size will give us our margin of error. So 0.0169. Just in case I need that. So they said round your answer to the nearest tenth of a percent. So if I move the decimal twice, because I need a percent, then that's going to be boom, boom. So that's going to be 1.69%, right? But that's the nearest hundredth. So I really should put 1.7% if I'm rounding to the nearest tenth. Okay, so there you go. Now, give an interval that is likely to contain the exact percent of the population that owns a smartphone. Okay, so we start from the middle value, which is the survey percent who owns a smartphone. And we add and subtract the margin of error. And our population percent should be in there somewhere. So we're starting with the survey percent of 76%. And then we're going to add or subtract our 1.69%. Okay. Yes, so we'll just go ahead and execute this. So if I do 76, oh yeah, but I wanted to use 1.7. Scary. All right, so if I do 76 minus 1.7, that will give me my lower bound. Okay, that's 74.3%. Okay, and if I do 76 plus 1.7, obviously that's going to be 77.7%. Okay, so there you go. Now, part C. What percent of the people surveyed are not smartphone owners? Well, 76% of the people own a cell phone, so that means the rest do not own a cell phone. So, 100% minus 76%, that's how you do it. So everybody else would be 24%. Okay, and there you go. All right, so that's it for number 7. Hope you enjoyed it. All right, let's move on to number 8. All right, a survey reported that 80.1% of people have texted while driving. Wow, that's a lot, by the way. Cut it out. If 1,057 people have texted while driving, how many people were surveyed? Okay, so this is not really an advanced algebra question. This is really like a middle school math question. Okay, they're saying 80% of the people, which we'll call N, but then they tell you how much that is. So 80% of the people turns out to be 1,057 people. So we have to we're basically finding 80.1% of what is going to give you 1,057. All right, and if we'll wind up dividing, and that'll give us a sample size. Okay, so the way you find the percent of something is you multiply it by the decimal form. So this really means that changing this to a decimal, 0.801 times n should equal 1,057. So if I divide both sides by 0.801, I should have it. Okay, so 1,057 divided by 0.801. Okay, so 1,319.6. I'm going to round that to 1,320. Okay, so that's the sample size. All right, so let's look back and see if it makes sense. All right, so this is saying that 1,057 people out of 1,320 people texted while they were driving. Okay, and does that give us 80%? So we could kind of check our answer and do 1,057 divided by what do we get? 1,320. Now, it'll be a little off because I did round here. But you can see that's going to be 80.1%. Okay? All right. Now, to the nearest tenth of a percent, what is the margin of error for the survey? Well, the margin of error is 1 over the square root of the sample size. So that's 1 over the square root of 1,320. Okay. Okay, and converting that to a percent as we move the decimal point twice, this will be 2 point, okay, there, oh, nearest tenth of a percent. So again, that's 2.8. I'll have to round up. All right, that's your margin of error. Now, give an interval that's likely to contain the exact percent of the population that have texted while driving. Okay, well, I'm going to do this plus or minus my margin of error starting from the survey percent. Okay, so I'm going to start with that 80.1%, and then I'm going to do plus or minus my margin of error, and that tells me that the exact percent of the population who has texted should be somewhere in between there. Okay, so let's subtract and add. So 80.1 minus 2.8. Okay, so that's 77.3%. Okay, and then 80.1 plus 2.8. Well, that's going to be 82.9. %. All right, so that was number 8C. So that's it for number 8. Moving on to number 9. The dentists in a dental clinic would like to determine if there's a difference between the number of new cavities in people who eat an apple a day and in people who eat less than 1 apple a week. Okay, so let's see. I like to mark this stuff as I go along. We're finding the difference between the number of cavities. Okay, so cavities is our response variable, by the way. Okay, so that's what we'll be comparing in the end, the number of new cavities. And anyway, here come the treatments. In people who eat an apple a day, okay, and in the people who eat less than 1 apple a week. So those are the two conditions that we're going to be comparing, all right, the explanatory variables. Anyway, the doctors look at patients' records and place them into 2 groups. Okay, group 1 is 50 patients who said they routinely eat an apple a day. Group 2 is 50 clinic patients who report that they eat less than 1 apple a day. Okay, so I see where we're going with this. I'm going to read the rest of it, but they're asking, is it an observational study or an experiment first? Now, did the doctors take a group of 100 people and then randomly assign them and have 50 of them eat an apple a day and have 50 of them eat less than an apple a week? Or did they just find people who are already doing that and just observe them and record the data? Okay, they did the second thing. This is an observational study because the doctors did not determine who's eating an apple a day and who's eating less than an apple a week. And here I've just written down what I just said. This is an observational study because the doctor does not decide who will eat an apple a day and who will eat less than 1 apple a week. The doctor just observes what the patients are doing anyway before the study began. All right, an example of a possible lurking variable in the context of the study. Well, there are a lot of different possible things you could come up with, but I'm going to say something like the people that are eating an apple a day might be generally more healthy. So, maybe they if they're healthy enough to be going out of their way to eat an apple a day, they might floss more too. Who knows? All right, so look at this. The people. Okay, wait. Yeah, the people that were already eating an apple a day might eat less junk food than the people who eat fewer than one apple a week. The lower amount of junk food might lead to fewer cavities for group 1. So, if it turns out that group 1 does have fewer new cavities, it might not have anything to do with the apples that they ate. All right? It might be that they're just healthier, apple eating, maybe they have fruits, vegetables, they floss, they might just be healthier eaters. All right? The non-apple eaters might be having more junk food on average, maybe even including candy. Gasp, all right? And drinking a lot of sodas and things that decay your teeth. So the apples might have nothing to do with it. That could be a lurking variable. Okay. All right, number 10. Administrators at a large urban high school want to get the students' opinions on who should be allowed to wear camouflage clothing to school. This high school has 700 senior students, all of whom are enrolled in a first period homeroom. There are 24 senior homerooms, each with approximately 25 students. School administrators select 3 of these homerooms at random and then include all of the students in the selected homerooms in their sample. Okay, so what is the population? Okay, administrators at a large urban high school want to get the students' opinion. Okay, that tells you what the population is. So the population is the students. So they didn't say seniors or juniors, or they didn't say anything specific. So, so it's the students at this high school. Okay, it's all of these students at this high school. So, now the sample. Let's see, what happened now? 24 senior homerooms. All right, here comes the sample. The school administrators select 3 homerooms at random, okay? And they said there were 24 senior homerooms. All right, so 3 of the senior homerooms. All right, each with approximately 25 students. So the sample is the 3 senior homerooms. Selected. That's the sample. And this will be about 75 students, 25 students per homeroom. All right, what is the sampling method used here? This is clearly a cluster situation because they picked whole groups at a time. Instead of taking a few from each, they picked 3 entire classrooms. All right, that's clearly the cluster method. Possible bias, yes, possible bias. Only seniors included. All right, the sample is 3 senior homerooms, yet the population is the students, all the students. So, a sample of all seniors. The rest of the classes are underrepresented. There are clearly not enough freshmen and juniors and sophomores to appropriately model the school. There it is. There it is. So moving on. Outline the following experiments. Be as specific as you can in your outline for full credit. Phys Laboratories, a pharmaceutical company, has developed a new pain relief medication. 60 patients suffering from arthritis and needing pain relief are available. Each patient will be treated and asked an hour later, about what percent of pain relief did you experience? Outline a completely randomized design for this experiment to compare the new drug's effectiveness with aspirin. So let me highlight a few things. So we've got the new drug versus aspirin. All right, those are the two treatments, all right, that we're trying to compare. Okay. I think I had one student include a placebo as well, and I thought that was cool. So if you did 3 treatments including a placebo, that's great. Let's see, what else am I saying here? Okay, so that's what's going on. So I think we are ready to set this thing up. Kabam! There you go. Just going to give you a few seconds to just soak in the beauty of this design. Simple yet elegant. Yeah, picture's worth 1,000 words, so moving on. Explanatory variable, response variable. The explanatory variable is going to be connected with your treatments, and the response variable is going to be your outcome that you're measuring. So this right here is your explanatory variable, and this right here is your response variable. So your explanatory variable is the it's not either one of these in particular, but if we could put both of these into some general category, like for example pain relief medicine. Okay, it's like which pain relief medicine you use. That's your explanatory variable. And then the response variable is the percent of pain relief. Okay, there you go. Moving on, number 12. Okay, apparently this question still refers back to the situation in number 11. Phys Laboratories realizes that their new drug may affect men and women differently. Typo. They conduct a new experiment with 20 men and 20 women to see if there's a difference in the pain relief based on gender. Each patient will be treated and asked an hour later about what percent of pain relief do you experience. Outline a block design for this experiment to compare the new drug's effectiveness with aspirin. Okay, great. So it's the same thing as before. So that makes it easier when you have Microsoft Word anyway. Because, you know, I'm going to start by just cutting and pasting this right here. Alright, did they leave me enough room? I think maybe they did. Okay, so I'm cutting and pasting this. So, since I'm going to have to run it for men and for women, then let's see, what are these 2 blue dots down here? Or did I steal some periods or something? Anyway, so I'm gonna have to cut and paste it twice because that's the nature of a block. You'll have more than one block, and we call it a block when we are running more than one parallel experiment on different types of subject. So, they conduct a new experiment with 20 men and 20 women. So instead of here having 60 patients, this is going to be my first block of 20. So I've got 20 men in my first block, and I've got 20 women in my second block. Okay, random assignment into their groups. So here I will have group 1, of course, will have 10 men. And group 2 will have 10 men. Alright, and in the second block, group 1 will have 10 women. And group 2 will have, group 2 will have 10 women. Okay, random assignment in terms of which group which gets which treatment, but we're still dealing with the new drug versus aspirin, and we're still comparing the percent of pain relief. So the rest of this is all the same actually, so I don't have to change any of that. So I'm going to tighten this up a bit, but that's what a block version of this particular experiment would look like if you separated men and women. Alright, let's move on to number 13. Okay, there are several psychological tests that measure the extent to which Mexican Americans are oriented towards Mexican Spanish or Anglo-English culture. Okay. Two such tests are the bicultural inventory and the acculturation rating scale for Mexican Americans. It's a mouthful. To study the correlation between the scores on these two tests, researchers will give both tests to a group of 22 Mexican Americans. Outline a matched pairs design for this study. Okay. Yeah, I'd like to just explain to you in English, like what this is saying, but it's kind of weird. This is a weird little, I don't want to talk about it. Anyway, the bottom line is we have 22 Mexican Americans are going to be the subjects, and the treatments are going to be these two tests. We're supposed to do matched pairs design, so the key of that is that each subject is going to experience both treatments. Okay, so we're still going to make two groups, but one group is going to get the BI test followed by the ARSMA test, and the other group is going to get the ARSMA test and then the BI test. Okay, that's how you do matched pairs. Check it out. Alright, well, we're going to start off with our subjects here, 22 Mexican Americans, and then we need to randomly assign them to their groups. So we're going to split them up into two groups. Alright, group 1 and group 2. Just because Mexican Americans is a long word, I'm just going to call them subjects. Alright, now these subjects, these groups of subjects, need to be randomly assigned their treatment sequence. So it's time for another random assignment. Now here come the treatments. Okay, one treatment is the ARSMA test, and then there's the BI test. All right. But since this is matched pairs, then everybody's got to get both tests. So we're also going to do the if anybody that had the AR-SMA test is then going to take the BI test, and whoever had the BI test is also going to take the AR-SMA test. Okay, and in the end, we're going to compare test scores, but let's make it real clear and be specific. We are not comparing group 1 to group 2. We are comparing same subject test scores. Okay, if Johnny is a subject, he took the BI test and the AR-SMA test. We're going to compare his BI test to his AR-SMA test. Okay, and we're going to do that for every subject. Anyway, that's what it's going to look like when you do a matched pairs study. Okay, let's move on to the bonus. A survey claims that between 45% and 52% of the population watches more than 2 hours of TV a day. What percent from the survey watches more than 2 hours a day? So it's kind of like we're working backwards from margin of error problems that we've worked with before. Usually we start with the percent from the survey, and we use the margin of error to come up with this interval for the population. But this time we're given the interval for the population. But remember, the way we get the interval is by adding and subtracting some number to the survey percent. So the survey percent is always right in the middle between these two extremes, all right, between the high and low. So an easy way to find that survey percent, the survey percent is going to be right here in the middle. Survey percent. Okay, it's going to be halfway between 45 and 52. So how do you do that? You just take the mean. You do 45% plus 52% divided by 2. All right, that will give you that middle number. Okay, so yeah. What was that? All right, 45 plus 52 divided by 2. Okay, that's 97 over 2. I'm more interested in a decimal, so that's 48.5%. Okay, so that is going to be the survey percent. What did I say it was? 48.5, yeah. Okay, so that's the number, the survey percent, that we usually do plus or minus the margin of error in order to come up with this interval that they gave us right to start off with. Okay, so keep that in mind, because I'm going to use that to figure out what the margin of error must be. Okay, so like I said, we usually use the survey percent. We usually do 48.5%, and then we do plus or minus the margin of error, and then that's how we get this interval, right? So that means if I did 48.5% plus the margin of error, let's just do it one at a time, that should give me the higher number. That should give me the 52%. And if I did 48.5% minus the margin of error, that should give me the lower number, 45%. Okay, because that's how we usually get this interval in the first place. So we're just working backwards. So it's like we're asking ourselves, okay, 48.5, middle number plus how much will give us 52. The middle number minus how much will give us the 45. All right, both of these little equations should give us the same answer. So we don't really have to solve it twice. So I'm just going to do the positive version. Okay, I'm trying to get the margin of error. So what I want to do is subtract 48.5% from both sides. Okay, and that should give me the margin of error. Okay, so 52 minus 48.5, That's 3.5%. Alright, and that is our margin of error. What else do they want to know? Okay, now they want to know how many people were surveyed. Okay, well, the number of people surveyed, that's the sample size. And the sample size shows up in our margin of error formula. So we know that 1 over the sample size, okay, that's the number of people surveyed, is n. Okay, so 1 over the sample size is equal to the margin of error. Right? Well, we just found the margin of error right there. So we're going to put this into the formula. Only I'm not going to put 3.5%. I'm just going to move that decimal over because this formula gives you a decimal form of it. So 1, 2, so that would be 0.035. So if I solve this, that should give me the sample size. Alright, do the reciprocal of both sides like you do, and that's going to give me the square root of n is going to equal to 1 over 0.035. Okay, square both sides. Okay, and that is going to give you the sample size. Okay, so that's 816.33. Sample size is always going to be a whole number, alright, because it's like a number of people surveyed. You can't have a third of a person surveyed. So I'm going to round this to the nearest whole number, which is simply 816. There you go. And I believe that is the last problem on this entire test. So that's going to be the end of this video. I hope it was helpful to you. And please, if you're practicing for a recovery test, at the very least, make sure you can do every problem on this paper by yourself. The bonus will not be a bonus on the recovery, so you better make sure you can do this problem as well on your own without any help.